Welcome to our Lab Exercise 7 video presentation. In this lab, we are going to show how to interface liquid crystal display with Arduino Uno board. The objectives of this laboratory are to introduce the student to Arduino Uno hardware, Arduino software, writing, compiling, downloading, and testing programs to control LED using digital outputs on the Arduino Uno, interfacing various devices such as LED, switches, and piezo buzzers. The materials we used in this activity are breadboard with Arduino Uno, adapter, keypad, 10,000 ohm potentiometer, 16x2 LCD, 4x4 keypad, 220 ohms resistors, LED, and piezo buzzers. For the pre-lab program, we are tasked to do the following procedures. 1. Connect the LCD and the rest of the components on the breadboard into the Arduino Uno. 2. Construct the test code below and open it by using Arduino software or IDE. 3. Make sure that you have chosen the right board and the corresponding port. 4. Then, upload the test code into your Arduino Uno. In this program, we use Tinkercad to show the simulation as well as the schematic diagram. The components used in this program are breadboard with Arduino Uno, 16x2 LCD, potentiometer, and one 220 ohms resistor. The code for this program includes the liquid crystal library and initializes an LCD object with specific Arduino pins connected to the LCD. In the setup function, it configures the LCD with 16 columns and 2 rows, sets the cursor to the second row, prints hello world, and leaves the loop function empty to keep the message displayed. Let us now explain the code. The first step is to include the liquid crystal library. This library provides the necessary functions to control the LCD screen with the Arduino. Next, we create an LCD object from the liquid crystal class. The numbers 12, 11, 5, 4, 3, 2 are the specific Arduino pins connected to the LCD. These pins will handle the data communication between the Arduino and the LCD screen. In the setup function, we initialize the LCD and display the message. LCD.begin16 2 initializes the LCD to have 16 columns and 2 rows. LCD.setCursor 0 1 sets the cursor to the first column of the second row. LCD.print hello world prints the message hello world. Finally, we have the loop function. In this particular program, the loop function is empty. Let us now see if it will work on an actual Arduino.
Program 1 involves creating and designing a display to show the graphics found on the cover page of the experiment handouts. This includes drawing the schematic using Tinkercad. In this program, we use Tinkercad to show the simulation as well as the schematic diagram. The components used in this program are breadboard with Arduino Uno, 16x2 LCD, potentiometer, and one 220 ohm resistor. The code for this program initializes an LCD with specific Arduino pins, creates custom characters for peace, love, and code, and displays these symbols along with their corresponding words on a 16x2 LCD screen. The setup function handles all initialization and display tasks, while the loop function is left empty to maintain the static display. To understand the code, first, the liquid crystal library is included to control the LCD screen. An LCD object is initialized with specific Arduino pins. Custom characters for peace, love, and code are defined using byte arrays. In the setup function, these custom characters are created in the LCD memory, and the LCD is initialized with 16 columns and 2 rows. The cursor is positioned to display the symbols in the first row and the corresponding words peace, love, and code in the second row. The loop function is left empty to keep the display static. Let us now see if it will work on an actual Arduino. Program 2 creates a message marquee system controlled by 2 light-dependent resistors. It displays 2 scrolling messages based on LDR input. If the left LDR detects light, the message "Welcome to the PCPE department" scrolls from left to right. Otherwise, the message "Goodbye, see you again next time" scrolls from left to right. The program involves initializing the LCD, reading LDR inputs, and implementing logic to control the marquee messages based on the LDR readings. The components used in this program are breadboard with Arduino Uno, 16 by 2 LCD, potentiometer 2, photoresistor, one 220 ohms resistor, and 2 10,000 ohms resistor. The code for this program initializes an LCD and sets up 2 light-dependent resistors on analog pins A0 and A1 to control the display of 2 marquee messages. The messages, "Welcome to the PCPE department" and "Goodbye, see you again next time," scroll from left to right based on which LDR senses light, with the LCD cleared if neither LDR is activated. To understand the code, first, the LCD is initialized and cleared. The loop continuously reads values from 2 LDR connected to analog pins A0 and A1. A threshold of 500 determines if an LDR has sensed light. Variables are set up to store message positions and track scrolling intervals. In the loop, if it's time to update the display, the LCD is cleared and the LDR values are checked. If the left LDR exceeds the threshold and the right doesn't, the first message scrolls from left to right. If the right LDR exceeds the threshold and the left doesn't, the second message scrolls. If neither LDR senses light, the display is cleared. This program controls the scrolling messages based on LDR input. Let us now see if it will work on an actual Arduino. Program 3 creates a decimal calculator that performs addition, subtraction, multiplication, and division. It accepts input from a keypad, displays the expression on an LCD, interprets the input, performs the operation, and shows the result on the LCD. The components used in this program are breadboard with Arduino Uno, 16 by 2 LCD, potentiometer, 2 photoresistor, one 220 ohms resistor, and a 4 by 4 keypad. The code for this program initializes an LCD and sets up 2 light-dependent resistors on analog pins A0 and A1 to control the display of 2 marquee messages. The messages, "Welcome to the PU-PCPE department," and "Goodbye, see you again next time," scroll from left to right based on which LDR senses light, with the LCD cleared if neither LDR is activated. To understand the code, first, we initialize the liquid crystal and keypad libraries for interfacing with the LCD and keypad. The keypad layout and pin mappings are defined. In the setup function, the LCD is initialized with a prompt for the user to enter a number. The loop function checks for keypad input. Digits and the decimal point are added to the input string and displayed. Clears the input. Hashtag ends the second operand input and triggers the calculation. The A, B, C, and D keys input the operators plus, addition, subtraction, multiplication, and division. When the calculation is triggered, the program parses the input string, performs the calculation, displays the result, and clears the input. Division by 0 displays an error message. Let us now see if it will work on an actual Arduino. Program 4 designs an Arduino circuit for a password-driven running LED system. The user enters a password via a keypad. If correct, a buzzer plays a correct tone, an LED run from left to right. If incorrect, a different LED pattern and tone play. The user has 3 attempts. After 3 incorrect tries, the keypad is disabled and the Arduino displays messages such as "Enter your name," "Enter your password," "Access denied," "Attempt already," and "Welcome with username," with some blinking for effect. To set up the password-driven running LED system, we first gather the required components: Arduino Uno, 4x4 keypad, 16 by 2, LCD with I2C module, 3 blue LEDs, 2 red LEDs, piezo buzzer, 220 ohms resistor, breadboard, and jumper wires. Next, We utilize Tinkercad to visualize the connections of each component. In Tinkercad, we add the components to the circuit, including the Arduino Uno, keypad, LCD, LEDs, buzzer, resistors, and connect them on a breadboard. Once the Tinkercad demonstration is successful, we proceed to the actual wiring connections. For the keypad, we connect the rows to Arduino pins 9, 8, 7, 6, and the columns to Arduino pins 5, 4, 3, 2. For the LCD, we connect SDA to A4, SCL to A5, and VCC and ground to 5 volts and ground respectively. The blue LEDs are connected to digital pins 10, 11, 12, the red LEDs to digital pins 13, A0, and the buzzer to a digital pin A1 with 220 ohm resistors in series with the LEDs. It is crucial to ensure the proper insertion of each component's connections to avoid errors. Finally, we upload the code to the Arduino IDE, making sure to install the keypad and liquid crystal _I2C libraries as needed for the program. Let us now see if it will work on an actual Arduino. Program 5 involves creating a custom LCD keypad video game with tone rendition. Using Tinkercad or Fritzing software, we draw the schematic to include an Arduino, LCD, keypad, and buzzer. To set up the LCD keypad video game with tone rendition, gather these components: Arduino Uno, 4x4 keypad, 16x2 LCD with I2C module, 3 blue LED, 2 red LED, piezo buzzer, 220 ohm resistor, breadboard, and jumper wires. Use Tinkercad to plan the circuit layout by adding the Arduino Uno, keypad, LCD, LED, buzzer, and resistors, and connect them on a breadboard to simulate the actual circuit. After demonstrating the circuit in Tinkercad, proceed to the actual wiring. Connect the keypad rows to pins 9, 8, 7, 6, and columns to pins 5, 4, 3, 2 on the Arduino. For the LCD, connect SDA to A4, SCL to A5, and V, CC, and GND to 5V and GND. Connect the blue LED to pins 10, 11, 12, and the red LED to pins 13, A0, with the buzzer on pin A1, using 220 ohm resistors in series with the LED. Ensure proper connections to avoid errors. Upload the code to the Arduino IDE, installing the keypad and liquid crystal. Underscore I2C libraries as needed. Let us now see if it will work on an actual Arduino.